to Caesar Snack Sandwich. Today I have a really quick video for you on Superform. Okay, Superform, as you can see, it's in closed beta right now. If you want to give it a test run, you can join the waitlist. But you're basically you can't use it, so you can't plug into it and actually play around with the buttons and stuff. And I wasn't able to do that. I was asked to just join the wait list, and then when there's actually live, I will have some early access to test it out. So everything that I'm going to tell you today is based 100% on the docs. I did read through the docs to the most extent. The docs is very technical. Basically, they go through every single contract and they show every single function. As far as I didn't verify that every single function is showed, but it appears to be that every single function is showed, described, and then displayed such as this. So I read through most of it. Like obviously there's some functions in here like decode time, load, payload, blah blah blah. I skipped over some of these functions, but I did read the cusp of every contract and the idea of this thing. Okay. So I'm going to use their flowchart to kind of talk about what this thing does and kind of how it works and some key points that are interesting and important. Okay, so the idea of Superform is that you can go from any of the chains that they are deployed on, and you can automatically enter volts on other chains just by using their user interface, right? So we have a couple things in here that are really important that really kind of make this thing important. So we have over here, they have this section where like, oh, the user has, gone to the front end of Superform and he said, hey, I want to use my ETH to enter this vault that you guys are, that is there on, I don't know, let's just say optimism. Okay. So maybe that vault on optimism has some random token. Maybe it takes ETH or something like that. But it's going to bridge and deposit for you, and kind of give you an NFT, an ERC 1155 NFT on the chain that you initiated the transaction. So in my case, it would be on ETH mainnet. Okay, so there's a few things in here that I really want to kind of really show that's important. Is this that they have an implementation of a 3-bridge system. So they will send the payload, your token, so to speak, across one of the bridges, but they will use at least another bridge to verify that it was done correctly. Okay, so they send a coded message across another bridge, and that bridge is like both of those bridges collude and say yes, this was done properly. Okay, so that's pretty interesting, right? Over here we have this DST swapper, and basically what that does is let's say I want to enter a vault that uses some shitcoin on another chain, and there's no liquidity to bridge to that token across, right? So what I have to do is that I'll have to send my ETH across the bridge, and then on the destination chain, I need to swap my ETH for that shitcoin and then enter it into the vault. Now there is one key point here is that you set the slippage, right? So when they send the ETH across the bridge, they won't be pulling the ETH back across the bridge if that swap fails because of your slippage settings. So what it will do is you'll basically end up having to go across the bridge yourself, like just change your wallet, right? And then claim your ETH back and then do the rest manually, okay? So it kind of, if that swap fails because of slippage, okay? Over here. So there's a few things over here. Now, these are the core contracts. These are these peripheral contracts. And these are basically contracts that are deployed specific to those specific vaults in a sense. This is the way I'm understanding it, okay? So basically they have these, they require that the vault be ERC 4626 standard. So like if you have a vault your project has a vault, and say, let's say it takes shitcoin or ETH or USDC or whatever, as long as it's ERC 4626 standard, then you can permissionlessly add it to this system. Okay, so basically, yeah. So it's just, to set the functions that are universal, right, standardized, right. They have this one here. It's called time lock form, and this is for like vaults that have like time delay cooldowns. Like sometimes you have it's still ERC 4626 volt, but it has a cooldown on withdrawal. So if you have to first initiate a transaction, says I want to withdraw, and you wait a bit of time, and then you can withdraw. So they've added this kind of time lock ones for that. So keep in mind that like everything that you're going to do is on your source chain. So if you're using mainnet and you send some ETH to Optimism, anything you want to do on Optimism, you initiate on mainnet. Okay, so keep that in mind. So maybe using mainnet as your source chain might not be the best choice, right? Because of gas and stuff like that. So when you open a position, you where's the other thing that I wanted to show you over here? Oh, I think it's over here. Anyhow, so when you open your position on in my case mainnet, right? They mint you this NFT, and this NFT, holds all the data of, I sent this there, that. But you can deposit into multiple vaults at the same time. So there's this one here. It's like, am I interacting with only one vault? Yes, and is it on the same chain as the tokens I want to deposit in my superposition? Yes or no. These are the functions that it'll call. So as you can see, you can do multiple vaults with the same transaction, right? So you can say, oh, I want to send my ETH to this vault and this vault on this other chain, or on the same chain that I'm on, right? And back to here. So that's a Superform router idea. So the payment helper is like just a contract that estimates the gas that it'll cost to do what you're asking the Superform router to do. And then the paymaster is to pay the keepers, because there needs to be something on the destination chain to execute those transactions and pay the gas, right? So you will pay in your source chain, like so in my case, ETH on Ethereum. And let's say I went to Phantom instead. I need to pay those Phantom keepers to execute those Phantom transactions. So the payment helper will estimate it, and then the pay master will actually pay the keepers what is needed, right? And if there's anything left over, I can get a refund, right? Or if for some reason something happens, it'll kind of wait there and be like, hey, we need more gas, send us some more gas money. And then you send them some more gas, and then that stuff can go through. Okay, so I think it's pretty interesting. Like obviously, I've skipped over a lot of little specific things, like a lot of little contracts and stuff like that. But I think you have a pretty clear understanding of what this thing does. And if you, as always, I'll encourage you to come to the docs, read the docs, and maybe if you want to play with this thing in the future, you can join the wait list and get in there, right? They do talk a little bit about on their Twitter about some audits that they've run and some like bug bounty type things. So I do see that they're taking it serious. This is some pretty cool stuff. Like there's a lot. The docs is really well done in the sense of, like, for technical docs. Maybe for layman's people, it's pretty intimidating and hard to consume, right? But I think my video here will give you a decent enough understanding of what's going on here, so that you can decide whether or not this is something interesting for you and you want to play around with it. So as always, I read the docs, so I'm sharing with you. Thank you so much for watching, and I hope this is useful, and goodbye.